Alright, in the last video we looked at strategies for factoring. We looked at factoring out the greatest common factor and then how to factor binomials. Now we're going to look at how to factor trinomials and then four-term polynomials. So the first one to look at is perfect squares. Again, here's a formula for a perfect square. When we say a perfect square, we're talking about a binomial that's a perfect square. If I square a plus b, what am I going to get? It's a plus b times a plus b. I don't get a squared plus b squared. You can't distribute an exponent over addition, only multiplication. So remember, this thing here would be really a plus b times a plus b. And foiling this out gives me a times a is a squared. That's the first term here. The outer is ab and the inner is ab. So ab and ab is what? 2ab. And last times last gives me b squared. Okay. Similarly, if I have a minus b quantity squared, that's going to fall out as a squared minus 2ab plus b squared. So the minus sign puts the minus there. Okay. So I see time and time again students that will say that a plus b squared is a squared plus b squared. This is wrong, and you will be severely disciplined for that. No, just kidding. But seriously, don't make that mistake. That is incorrect. That is bad algebra. And again, 9 times out of 10, the problems that you have in this class are your algebra. You have to clean up your algebra skills to do good in calculus. So work hard at it. Make sure you understand what's going on here. Do not do this. Do not do this. That is incorrect. Okay. So, but we're going the other direction, right? In other words, if this is the expression, it factors as a plus b times a plus b. And so let's see, how does it meet this form? This thing here has to be a perfect square. Is it a perfect square? Yeah, 3x. Quantity squared is 9x squared. Is 16 a perfect square? Yeah, 4 squared. Okay, so the question is, this thing in the middle here, is it 2ab? This is a, 3x. And b is 4. Is that what 24x is? Yeah, 2 times 3 is 6 times 4. That's 24x. It is in the form that we need it in. This is a squared plus 2ab plus b squared, where a is 3x and b is 4. And so this is just going to factor as a, 3x, plus b, 4, quantity squared. End of story. Perfect squares are perfect for factoring. Lots of fun. Easy. Again, check by multiplying this out. Foil this out. 3x plus 4 times 3x plus 4. 3x times 3x gives me the 9x squared. The outer and inner are 12x, so 12x and 12x is 24x. Last times last, 4 times 4, 16. All right. Let's take a look at this. Now, this is not a perfect square, obviously. I mean, 2 is not a perfect square. Negative 5, that's not even going to be possible, right? So this is not a perfect square. So what do we do in this case? Well, now we're going to talk about a couple of methods. You might have heard trial and error. You might have used AC method. I don't know. Other people have shown different ways. If you all you do is you use some sort of your calculator or technology when it comes to factoring like these, then you need to learn how to do this. This is something that is required for this class. You cannot get by with just using your calculator to do these things for you. So let's take a look at this. How does this work? I'm going to show you the trial and error method. The trinomial can factor as a product of 2 binomials. Okay, and when I look at this, I know right away that the first terms for my 2 binomials, because 2x, because 2 is prime, it's going to have to be a 2x and x. That's the only way. 2x times x is going to get me a 2x squared. So if this thing's going to factor as a product of 2 binomials, I know that's got to be the case, right? 2x times x give me 2x squared. And the last is negative 5. The 2 terms here have to multiply together to give me negative 5. So how can you get negative 5? Well, you can have a positive 5 and a negative 1. That's a possibility. Okay, but you can also have a negative 5 and a positive 1. Right? Negative 5 times positive 1 is going to give me negative 5. But also I can have a 2x plus 1 and the x minus 5 over here. I can have the 1 with the 2 and the 5 with the x. Again, that gives me negative 5. Or I can get what? 2x minus 1, x plus 5. So there are actually 4 trials. This is the trial and error method. In other words, we have 4 possibilities. That's it. If this thing factors, it's going to factor as one of these things. Because the only way to get 5, negative 5, is multiply 5 times 1, where 1 is positive and 1 is negative. And the only way to get 2x squared, multiplying by 2 things, is 2x times x. Right, well, I mean, you have to have, you're not going to have 2x cubed here and 1 here. That's not the way it's going to factor, right? And so, what do we have to check? We have to check the outer plus the inner terms in our foiling, right? And make sure they do what? Add up to 9x. That's the key. So when I look at here, the outer is negative 2x, and the inner is 5x, and that gives me 3x, right? Well, error. That doesn't work. I need 9x. This is not the one. This is incorrect. Here, if I do the outer, I get 2x, and inner is negative 5x. That's going to give me negative 3x, right? Which is also incorrect, right? By the way, if you swap the signs here, that's exactly what's going to happen to your inner and outer sum. Your outer and inner sum is going to just change sign, right? That's all that's going to happen. Here, I get the outer is negative 10x, inner positive x. Negative 10 plus 1x is negative 9x. That's not going to work because I need positive 9x. Well, I know now that if I swap my signs, that's going to give me positive 9x, and this indeed is the one that wins. Now, this is an easy trial and error one, and if I have prime numbers at the beginning, at the end, I'm always going to do trial and error. It's very easy in general. There's typically not a lot of trials. Now, if instead of 2 here I have like a 24, and instead of 5 I have 60, then the number of trials can be quite a lot. You might have 20 different trials. There's techniques you can use to eliminate trials. For instance, as long as you've factored out the greatest common factor, none of these single binomials should have a common factor. So you couldn't have a 2 and a 4 here or something if you factored out the GCF. So I mean, you can eliminate some of your many trials, but there could be a lot of trials there. Okay, we'll look at the AC method as another technique for factoring in a minute. But here's this thing completely factored. Let's look at this one. Here's a trinomial. Before I get going, though, what jumps out at me right away is there a greatest common factor? Don't forget that from the last video. Yes, the greatest common factor here is 3x, right? So 3 is the common factor, greatest common factor of 3, 9, and 6. And remember, x cubed, x squared, x, I pull out x to the smallest power. So if I pull out a 3x from this, what's that going to leave me? X squared minus 3x plus, what, 2. Right? And double check that this works. 3x times x is 3x cubed. 3 times 3 is 9x squared. There's my negative 9x squared. 3 times 2 is 6. I get my 6x. So as a quick check. Now, this thing, very easy to factor. Notice the coefficient here is 1, so this is so easy, right? If the coefficient in front of the x squared term is 1, if this thing factors, you're going to know right away. Because now all you're talking about is the last times last has to be equal to, right, multiplies to positive 2, but they have to add up to what? Negative 3. So what two numbers multiply to give me positive 2, but add together to give me negative 3? Well, obviously they're both negative numbers, and the answer is negative 2 and negative 1, right? If I multiply negative 2 times negative 1, I get positive 2, but when I add them, I get negative 3x. And so my outer is negative x, my inner is negative 2x. They add to negative 3x. And there is my factored expression. Okay? Now, let's take a look at four terms. So as we said in the general strategy, if there's 4 terms, we can try factoring by grouping. So what's grouping? Grouping doesn't always work, but in these cases I've set up, it will work. We look at four terms. First of all, you should ask, is there any greater, GCF I can factor out of all four of these? And the answer in this case is, other than one, really nothing worth factoring out. And so, there we have it. We're moving on to what? Trying grouping. How do we do that? We look at the first two terms. We group the first two and group the last two. We try it this way first of all. Can I find a greatest common factor from just the first two? Well, yeah, I can factor out an x squared from the first two, right? So I can factor out an x squared. So by the way, this is grouping. I can factor out an x squared, and what's that leave me? 3x minus 2 from just the first two. But what about from the next two? Is there anything I can factor out of there? You say, well no. 3x and a negative 2 plus 3x and a negative 2. There's nothing I can factor out of that. But look at this. I'm left with a 3x minus 2 here after I factor out an x squared from the first two terms. So if I factor out a positive 1, when would I want to factor out a 1 from anything? Answer, when you're doing grouping. All right, I'm going to factor out a 1, and what's that going to just leave me? Well, 3x minus 2. So the point of this is, if I can factor something out of the first two and something out of the second two, even if it's 1 or negative 1 or whatever, and the important thing is what? That I'm left with the same factor in each. Is that the case? That's the goal. If you have the same binomial, in this case factor, right? Then what? This factor can be pulled out of these two terms. Notice this plus sign right here is essentially right here. Don't forget this is plus right here. Right, so it's this whole term plus this whole term. And the 3x minus 2 is common to both. So that's the greatest common factor of these two terms now. What's that leave me? An x squared plus 1. And this is factored. All right, I can't factor x squared plus 1 anymore. That's factoring by grouping. Let's do another one. Factor by grouping. Let's just try that again. Okay, this one, again, I take a look and see, is there any common factor that I can pull out of here other than 1? And the answer is no. I've got 5, I've got 2, there's nothing common that I can pull out that I'd want to pull out there. So what do? We look at the first two terms, right? Group those two together, and then we're going to group the second two terms. What can I factor out of the first two terms? Again, the answer is what? X squared. And that's going to leave me a 5x minus 2. Now, what can I factor out of the next two? Now you say, hey, I can factor something out of here. I can factor what? 20 and 8. I can factor out a 4. I can factor out a 4. But the problem is, if I factor out a 4, I'm going to be left with negative 5x plus 2. Negative 5x plus 2. I want positive 5x minus 2. So instead of factoring out a positive 4, what do I need to factor out? A negative 4. So it's plus a negative 4, or just I can write minus 4. And what's coming out right now, I'm going to have what? Positive 5x, rather. Negative times positive will give me that negative 20x. And then minus 2. Negative 4 times negative 2 gives me that positive 8. And again, the important thing is to see that you have the same factor here. It has to be exactly the same. You can't have 5x minus 2 and negative 5x plus 2. That's not going to work. If that's the case, you need to factor out a negative. Negative 1. So what do I have? 5x minus 2. Factor that out. What am I left with? X squared minus 4. This time, though, unlike the last example, this one can be further factored, because what do we have? From the last video, we talked about what? Difference of squares. This is x squared minus what? 2 squared. This factors as the difference of squares. X plus 2 times x minus 2. Okay. So grouping. Now, I want to show the AC method going back to a trinomial, and it's called the AC method. Sometimes it's actually called the grouping method. You say grouping, I thought that was 4 terms. Well, we're going to change this 3-term, this trinomial, 3-term polynomial, into a 4-term polynomial and use the grouping technique. So how do I do that? I'm going to break up this negative 8x into the sum of two things. And how do I do that? Sometimes called the AC method, right? If you remember, in general, we talk about a trinomial of degree 2 ax squared plus bx plus c, right? Where a, b, and c are the coefficients. A is 12, right? B is -8, and c is -15, right? So it's called the AC method because I want to look at the product AC. A times c is 12 times -15, which is -180. Okay? And here's how the AC method works, essentially, right? To figure out how I want to break this up, I want to break this up into the sum of two terms, mx plus nx, where m and n are two numbers that basically add to -8. Okay, they have to add to -8. So I want to have m plus n equals -8, but I want the product to be equal to AC, which is -180. That's the m plus n that I need in order to get this in a four-term polynomial form, in order that grouping will work. And so the reason this is nice is now it's kind of like going back to the case where you have if you had a degree 2 trinomial where the coefficient instead of being 12 was just 1, right? And then it's real easy because you're just looking for what's the product that is equal to what? -15, because AC in that case would be 1 times -15, would be -15, and adds to what? -8 again, right? So it's an extension of that idea. And it's a little bit easier now. Trial and error, if you go back to trial and error, it's going to be hard to do. There's lots of numbers, products of numbers that give me 12, right? 12 times 1, 6 times 2, 3 times 4. You know, same with 15, 5 times 3. You know, so maybe not in trial and error. There's not too many, but again, it could be worse. But here we want to look at two numbers whose product is negative, whose sum is negative. That means obviously if their product is negative, then one is positive and one is negative. But since their sum is negative, the negative one is larger in absolute value. Now, you might not have to go through the whole list, but you know, a way to start is to start with -180 times 1, right? That negative number is bigger than the positive number in absolute value. The product is -180, but the sum, right, if I look at m plus n, the sum is going to be -179. That is not close at all to -8, so that's incorrect. Okay, but we just keep going down the list, right? 2, does 2 go into 180? Yeah, 90 times, so -90 and 2. But if I add them, I get -88, right? Well, that's not going to work either, right? That's no good. Does 3 go into 180? Yeah, 60 times. -60 and 3, but they add to what? -57. Okay, so that's not going to work. So you kind of get in the core. If this works, we've got to keep going until we get to a sum that's -8. I'm just going to go ahead and list all the other ones. 4 does not divide into 180 evenly, but 5 does. It goes 36 times. All right, but -36 plus 5 is -31, and that is not -8. Does 6 go into 180? Yes, 30 times. -30 times 6. If I add those, I get -24. That is not -8. Does 7 doesn't go into it? Does 8 go into it? No. 9, yeah, 20 times. -20 times 9 is -180. If I add these, I get what? -11. Still not good. Does 10 go into that? Yeah. -18 times 10, and finally when I add these I get -8, and there's my winner. Now, you don't have to go through this whole list. I mean, if you just automatically knew that off the bat, you say, hey, I can see that. That's great. But sometimes you have to systematically go through it to find it. By the way, if you go through the whole list of all possible factors that give me this product, but you never find the sum, then it's prime. Then you wouldn't be able to factor it any further if that were the case. So what do? We're going to rewrite this as 12x squared, and then the -8x I'm going to write as -18x plus the 10x. Right, -18 plus 10 gives me -8. So this right here is equal to -8x, which we had from the beginning. Don't forget the -15, right? So I've written this three-term polynomial is a 4-term polynomial. They are equal. This and this are equal. But now we can use the grouping method, right? So I can factor from the first two what? Well, 12 and 18 have a common factor of 6. X squared and x has a common factor of x. What's that going to leave me? 2x minus 3. What can I factor out of these two guys? Well, 5, right? If I factor out a 5 from 10, that leaves me what? 2x. 5 from 15? Minus 3. Right, it's minus. And there it is, right? The 2x minus 3 is common to both. I can factor that out. And I'm left with 6x plus 5. And there's the factored form. So that's the AC method, sometimes called the grouping method. Again, I've shown you trial and error, I've shown you grouping, or the AC method. Use whichever one you want. If you have another way of doing it, that's fine. If you're simply using a calculator to do it, or some program or some app, and you have no idea what you're doing on this, you really can't proceed through calculus in that manner. Okay, there's going to be skills that you're going to have to be able to do without any calculator, without the technology. You really need to be able to factor. This is critical. This is a critical skill. Okay, so work hard on it, and let me know if you have any problems.